I am Anil Kumar. Welcome to my series on Combinatorics. Here is an introduction to the topic. Combinatorics is a branch of mathematics where we are dealing with counting and arranging discrete items. So whenever we have to count very big numbers, then there are some special techniques to be used, which we are going to look into in this particular video. So combinatorics applies mathematical operations to counting quantities that are much too large to be counted in conventional ways. So we look into different counting techniques. Tree diagrams are very easy to use. We could use matrix also. But we'll go through with some rules which will help us do this counting much easier. We look into the fundamental or multiplicative counting principles, indirect methods of counting, additive counting principles, or the rule of sum. And then we look into some combination of these with the help of test examples. So let's begin with the basics. So we have an example here, and that says that Anil wants to go by bus, train, or by plane to either Detroit or Boston. How many ways can this be done? So there are three ways of transport: bus, train, and plane, and there are two destinations, Detroit and Boston. Now, how many combinations do we have here? You could solve this question using a tree diagram as shown here. So these are the three options and then the two cities, and that clearly gives you in all six options, right? So we have six ways of meeting this target. You could also do it with the help of a matrix by drawing a table. In this case, you could have two rows and three columns. Now the two rows which I have shown here are the destinations Detroit and Boston, and the three columns are bus, train, and plane. Well, that also gives you six cells or six choices. You get the idea. Now, these techniques are very efficient if the data is very small, as in this particular example, and very conveniently, we can figure out the choices. But there is a rule of product, which we have seen here in both the cases, rows into columns, or the number of branches here are the products, 3 into 2. Perfect. And that gives our first rule of counting, right? So here you will notice that the process is made up of two independent stages, right? One stage is mode of communication. The other stage is selection of the destination. So mode of communication, three options; destination, two options for us. So in all, what do we have? We have six options, correct? So as you can see here, we have travel mode by two options, destination is by two options, travel mode is by three options, bus, train, or plane, and destination two options, Detroit or Boston. So the total number of choices are 3 times 2, which is 6. And this is called the rule of product. Now let's explore this rule of product. How can we use it very effectively? We'll follow up with some examples. Now, we call this as a fundamental or multiplicative counting principle. If a task or a process is made up of stages, as it was in this example, with separate choices, the total number of choices is the product of each independent choice, correct? So as in the last case, 3 times 2, right? 3 choices for mode of transport and 2 for the destination. So in that way, we could actually extend it to any number of choices. The condition is that they should be performed in a sequence, right? And so for choice 1, if we have m options, for second, if it is n options, and then p options, then the answer is product of all of them. And that is what we call as fundamental or the multiplicative counting principle, correct? Let's take a few examples to understand it. Example number one here is an ice cream parlor has 20 flavors with 10 toppings option and 3 different size options. How many different choices is the ice cream parlor providing to the customers? Well, there are 20 flavors independently, right? Times 10 toppings and 3 serving sizes. So we can just multiply the 3 and get the total as 600 in this case. How simple it is, correct? So if you identify that there are 3 independent ways which could be done in a sequence and operation, you understand, in that case, just multiply them and get the answer. Let's take another example, example 2. How many ways can you answer true or false test consisting of 25 questions? So we could say true or false. That means we have two options, right? For every question, we have 25 questions, 2 times 2 times 2 times 2. So 2 to the power of 25 will become the answer. So keep on multiplying by 2 every time, right? There are 25 questions, so every 2 gets multiplied and we get 2 to the power of 25 as the answer of this question. Now let's look into question number 3, which is a standard die is rolled 5 times. How many different outcomes are possible? So we have used a technical word, outcome here, which will be very popularly used when we talk about probabilities, right? So number of outcomes means what results come out of a single throw of the dice. So when you throw a die, you get 6 options, correct? So every time you throw, we get 6 options, right? So if I do it 5 times, then it will be 6 to the power of 5 as our answer. Perfect. So that is how we could apply this rule of multiplication and get quick answers to some questions. Now let's look into another method of doing these things. Sometimes we also follow indirect method of counting. Now let's look into this indirect method of counting. Example here is there are 5 pair of gloves in a basket. In how many ways can 2 unmatched gloves can be pulled out from this basket? So in this case, we are pulling out and we are interested in finding unmatched gloves, right? Now there could be many options to get unmatched gloves. When we say indirect, we say, well, what we could do here is we could find total options, right? And from them, we could deduct matched options. And that will give us the options for unmatched. Does make sense? So that is what we are calling as indirect. Perfect. So we could do it like this. So that is our strategy. So the strategy here is that we can find the number of ways of picking unmatched pairs of gloves by subtracting the number of ways of picking the matching ones from the total number of ways of picking any two gloves. Perfect. Now let's see how to solve it. So there are 10 ways of pulling first glove and then 9 ways of getting the next. So what we're trying to say here is, let's say there are 10 gloves, right? So we have to just pick 2. So we have the option, whenever we try to pick it for the first time, we could pick any one of those 10. And the second time, since one has been picked, we have 9 left there. So there is option to take 9 now, right? So there are 10 ways of pulling the first glove and then 9 ways of getting the next, since we have picked one. From fundamental counting principles, the number of ways of pulling the 2 gloves is 10 times 9, which is 90. Right? So we get the total options of pulling these pairs. So there are 90 ways of pulling the pairs. Now, there are 5 matched pairs, right? Now, when you have 5 matched pairs, then these can be picked by first pulling out left and then right, correct? Or by first pulling out the right and then left. So both ways you could match a pair. So there are 10 ways of getting the matched pair gloves, right? So first 5 are the correct ones of the left side, and then you pick up from the right side, right? So that is how we have 10 options, 10 ways of getting a matched gloves. And unmatched will now be difference of total with the matched ones, and we get 80 ways as our answer. So that is what we're calling as indirect method. Perfect. So it is easier in this case to figure out how many options are there for pulling out matched pairs, and therefore we found our answers indirectly. And it's a very efficient way of working. Now let's look into the second principle, which we call as additive counting principle or the sum rule. If you can choose from either m items of one kind or n items of another kind. So there are two types of items, right? Mutually exclusive, we say. There's nothing overlapping here, right? So if you can choose from either m items of one kind or n items of another kind, then the total number of ways is m plus n. Additive counting principle, right? That is what we call as additive. And this is like we have OR operation going on, correct? So either this or that. That is what we call additive. Note, the events M and N are mutually exclusive as they cannot happen at the same time, right? This is very important. So the two events should not be overlapping. They should be mutually exclusive. Nothing common between the two. Example here is, how many ways are there to select a king or a blackjack from a standard deck of cards? Well, if you select a king, you cannot select a blackjack, correct? So there's nothing overlapping. So these type of events are called mutually exclusive, right? Now, as you know, in a deck of cards, we have 52 cards, correct? Amongst these 52 cards, we have 13 of each, like spades. We have 13 hearts. We have 13 diamonds. And 13 clubs. These are called suits. So there are 4 suits, each 13, right? We know that 26 are red cards, and we know that 26 are black cards. The numbers go from 1 to 10, and then we have jack, queen, and king. 1 is like ace, right? So these are the 13 cards which you are playing with. So now in this particular case, as you can see, we have 4 kings, correct? So there are only 4 ways of selecting a king. Now we're talking about blackjack. There are 4 jacks, out of which 2 are blackjacks. 2 are the red jacks, correct? So the red ones are the hearts and diamonds. These are red. So, and the black ones are club and spades. So when we are saying 2 ways of selecting blackjack, that means there are only 2 cards. So we have in all 6 ways of getting either one of those kings or one of those blackjacks, right? So how many ways are there to select a king or a blackjack? Either one of these two, right? Since there are only 4 kings, those are the 4 ways. And since there are only 2 blackjacks, there are 2 ways. So in all, we have 6 ways of selecting a king or a blackjack card. So keyword is or here. In that case, you can add, right? Let's take a few examples now based on this. So here, we'll talk about combination of both product and sum, as that may be the case in many times. So many times, both multiplicative and additive rules are applied. Here is an example. How many different signals are possible with a set of 4 distinct flags? Let's say we have 4 flags. Their colors are blue, red, green, and yellow. So they are very different flags, different colors. If a minimum of 2 flags is used, so the question is, how many different signals are possible with a set of 4 distinct flags if a minimum of 2 flags is used? Now, when we say minimum of 2 flags is used, that means that you could use 2 flags, you could use 3, or all 4, right? So these are the 3 cases. So we call them as cases. So we have to work them separately. So we have accordingly defined our cases. Case 1 using 2 flags, case 2 when 3 flags are used, and case 3 when 4 flags are used, right? So we can use 2, 3, or 4 flags to create different signals. Their combinations will give different meanings, right? They form 3 mutually exclusive events. Results of these 3 cases can be added. You understand? So if you are using 2, you are not using 3 flags, right? So they are mutually exclusive. Now, let us say that you are using only 2 flags. That means we can think about 2 positions to be filled. Since you are using 2 flags, but we have how many? We have 4 flags in all, correct? But we are using 2 for signaling. In that case, you have a choice of 4, but once we pick up one of them, in that case 3 are left. So we get 4 times 3 as 12 as the number of choices when 2 flags are being used. Well, if you're using 3 flags, in that case, to pick up the first, we have 4. Then once we have picked up a flag, 3 are left, and if that has been also picked, then we have a choice from 2. So the total is 4 times 3 times 2, which is 24. Now, if you have to use all the 4 flags, which is also an option, in that case, first you have a choice for 4, then 3, then 2, and then 1. So we have a choice of 24 options when all the 4 flags are used. Now, total is all the 3 cases together. Since the question says that a minimum of 2 flags is used, that means 2 flags could be used, 3 flags could be used, or 4 flags could be used. Perfect. So we can add them all to get our answer, which is 60 signals. So we can provide 60 signals by using 4 flags and at least 2 of them together. Perfect. So that is how, as you can see here, we have used both the principles, the multiplicative for individual options, and then since the events are mutually exclusive, we added the results. Now let's take some more examples. Now here is a practice test question example. The question is right before you. I'd like you to pause the video, answer the question, and then look into my suggestions. A 4-digit number is formed by using the digits 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers and we are only choosing 4 of them. No digit can be used more than once. Find the number of 4-digit numbers that can be formed if there are 3 cases. First, there is no restriction. So if there is no restriction, then how many 4-digit numbers can be formed using the numbers 1, 2, 3, 4, 5, 6, and 7? That becomes the question. Question number 2 here is the number less than 4,000. So you have to form a 4-digit number which is less than 4,000 using the digits 1 to 7. And third option is that the number is even and less than 4,000. Perfect. We'll use our rules of multiplication or addition to find the answer, right? So I've made 4 boxes here. Think about choosing a number in each box, correct? So that will give you a 4-digit number. So now, if you look into the first case, which is there is no restriction, we have to make 4-digit number using these 7 numbers. In that case, in the first box, I have a choice of 7 numbers, correct? So I can choose 7 numbers for one box. Once I do that, then I'm left with 6 numbers. So I can choose from those 6 numbers When I pick up the 2, I'm left with 5, and then I'm only left with 4. So the total number of choices for the first case, when there is no restriction, is 7 times, 6 times, 5 times, 4. Is that correct? So that is how we could easily answer the question using our first fundamental rule of multiplication. Since these are independent events, right? So first box we could choose 7. Once it has been chosen, then we are left with 6 numbers to choose from, and that is how we get our answer. So now I'd like you to answer question number 2 and question number 3 on this information. Okay, so I hope you got the answer. Now let's look into how do we work with it. Number less than 4,000. When I say that the number is less than 4,000, that means the choice is restricted. I can only use 1, 2, and 3 for the 1,000 place, right? So at this place, I can now choose only one of these 3. So therefore, here I have only 3 options left. Now, if I choose one of these 3 for the 1,000 place, in that case, I am left with 6 options, and there is no restriction to that. Any 6 of those could be now chosen. The number is going to be less than 4,000 for sure, and then 5 and then 4. So in this case, the choices will be 3 times, 6 times, 5 times 4. You can always multiply them and get your answer. Of course. Now the question here is, the number is even and less than 4,000, right? So I'd like you to think about it. Even means what? Even means that the last digit is now restricted. We could only have 2, 4, or 6 in the last place, right? And also we have a restriction that in the first place we could only have 1, 2, and 3. Now we have got 2 types of restrictions. One where the last digit could be only 6, 4, or 2. You can clearly see that if 2 is in the last place, in that case, in the first place, we're restricted with only 2 numbers, 1 and 3. You get the idea. So those are different cases to work on. So I'd like you to focus on this and then look into my suggestions. Okay, let's move on and see the results. Well, the first case was very clear, no restrictions at all, and you found it will be 7 times, 6 times, 5 times 4, getting the answer of 840. No restrictions. Now, in the second case also, we saw that we wanted a number which is less than 4,000. So first position was restricted to 3 choices, 1, 2, or 3, and then 6, 5, and 4 were the choices, and the results into 360 choices. Now, we're trying to figure out the number of ways that the number is even and less than 4,000. So clearly, the choices for the first digit are 1, 2, and 3, and the choices for the last digit are 2, 4, and 6. Now, based on this, we have to work out the details, right? So we have 3 different cases to work with. Now, let's look into these cases one by one, correct? So now, the number is even and less than 4,000, right? That is what we are now looking into. So let's see. The number is even and less than 4,000. That means the ending numbers are 2, 4, and 6, and the starting numbers are 1, 2, and 3. Now, important thing here is to understand what is our main restriction. Even numbers? Well, let's take that as our main restriction. So that means we'll first fill up the ones place, right? So ones place could only take these 3 items. So we'll start with the ones place. That is fixed. Now, once we have fixed that, in that case, dependent restriction is that the starting position cannot have the number which has been fixed, right? So let's call this as a dependent number. Well, once these 2 are filled in, then in between, there is no difficulty. We will fill in the remaining, correct? So 1 and 2 are gone. So out of 7, 2 are gone in the first and the last case. So we are left with how many? 5 and 4. So they will take the next 2 places, correct? Of course. Now let's see each case one by one. So let's work out the first case which is case 1, where the number is ending with 2. Now, if the number is ending with 2, let me write down a number ending with 2 here, right? So let's write down 2 ending number here, okay? So if number is ending in 2, then in the first place, I cannot write 2. I have only choice for 1 and 3. Do you see? So that means when number is ending with 2, I have a choice of only placing two numbers in the first position, correct? So I have utilized two numbers out of 7. 5 are left, that is placed here, and then 4 left goes to the next position. So when I place 2 in my final position, in that case, there are 40 ways of filling this up, right? Now let's look into the case 2. Now case 2 is ending with 4. Now if I write 4 over here as the last option, in that case I have all the three numbers 1, 2 and 3 which can be placed here in D, right? Do you see that? And therefore, as you can see clearly, we have three options. And for those two, of course, 5 and 4, which is common, right? We have placed two numbers, we are left with 5 and then 4. So we get total of 60 options. Similarly, if I choose 6 as my last number, in that case, again, I have three options for the first one, which are 1, 2, and 3, correct? So again, I've got 3 times 5 times 4, and same result as 60 as the last time. Now, in the three cases which you're talking about, we can add them up to get the total number of ways of having even numbers less than 4,000. So that is 160. 40 plus 60 plus 60. Is that clear to you? So when we are talking about the counting principles, it is a good idea to think about a space, right, which I could make like a box or a simple line. And with this space, we can write the options and multiply these options. Let's say if this option is m, this is n, and this is p, then the answer is m times n times p. Is that clear to you? Okay, so that is how we are going to do it. Now here is another type of counting which is very popular, especially in probability cases. So let's see. The question here is, write the total number of ways of rolling a sum greater than 7 with two fair dice. That means, a dice has 6 faces, correct? So those 6 faces have 6 numbers on them. And those numbers is what we are talking about, correct? So that's our dice. And on this die, we have numbers mentioned, correct? So let's say this is one number, and then let's say this is like this, numbers are written, correct? So in this dice, when you throw, there are 6 options. These options are given to you in the form of rows and columns, as you can see here, correct? So 2 dice, so one die, we are saying die number 1. So this is number 1 here, and that is number 2. So when you throw them, you can add the numbers, and the addition goes in this particular matrix form. Is that clear to you? We're looking for a sum greater than 7. So this row here will give you 7, right? So 6 plus 1 is 7. This is the row which will add to 7, correct? So if you add 6 and 1, you get 7. The row, that diagonal I should say, 6 and 1, 7, right? 2 and 5, 7. But if the number is below it, that is 6 and 2, we get an addition here, 8. And if it is above it, we have a smaller number. Do you see that? So all these are the cells in which the addition will be greater than 7. We can just count them. And once you count, you see that there are 15 of these. And therefore, there are 15 ways of getting more than a sum of 7 when 2 dice are thrown. There are 36 in all choices, right? 6 times 6. So there are 36 choices out of which 15 is with sum greater than 7. Is that clear to you, right? So that is how you could easily sketch and get your answer. So what we discussed here are different ways of counting, and that is combinatorics. Now, in combinatorics, the numbers could be very large, as we saw, and these simple methods are effective for smaller numbers, especially the tree diagrams and the matrix. However, we could use the counting principles. The one which we decide on is the multiplicative counting principle if we have independent cases and they are done in a sequence, then each option can be multiplied. And the other one was if we have mutually exclusive, no overlapping, independent cases, in that case, we could add the options. And we also saw that sometimes we may have to use more than one alternative, right? So these are different ways of working with counting and arranging. So I hope that is interesting. We'll now take up more examples and also understand permutation and combination before getting into probability. I hope that gives you a good foundation. Thanks for your time and all the best. You can always contact me on this email address if you want to learn from me. Thanks for your time and all the best.